Welcome to the newest lecture on Algebra 1, and today I'm focusing on slope, which is also called rate of change, but in Algebra 1 we focus on the word slope. And slope is defined as the change in the y values. That triangle means change in. It also is called delta. But the change in the y values divided by the change in the x values. We also call it rise over run. The rise is the vertical change and the run is the horizontal change. Also, the rise has to do with the y values of ordered pairs, and the run would be x values or the horizontal change in the ordered pairs. Now, all this stuff is taken from this textbook here. Any problems I happen to grab. So if this is your textbook, you're in luck. If not, I'll even put a link in the description where you can find it. So let's get on with slope. Now, getting on with this idea that the change in y over the change in x and rise over run. Well, this rise over run is used often when we have the graphed line. And we can see here that we got two dots here. We have one dot, which is right down here, and another dot that's right up here, and we're asked, well, what's the slope? Well, that is to say, what is the rise? So from that dot to the other dot, let's go vertically. 1, 2, 3, 4, 5, 6. So when I meet the other dot, that goes up, it goes up 6 spaces. And then going to the right is 1, 2, 3, 4, 5, 6, 7, 8. And it goes to the right 8. So the slope, which we often call m for a strange reason, m, slope, is the rise over the run. The rise was 6 and the run was 8. And that certainly is correct. So that would be an answer. But it's not the only answer, because I also happen to see that this line crosses through this part of the grid as well. Notice it misses the grid right here. It misses the grid intersection right there, and it almost gets it there, but it hits it right there. So we actually could have used these two dots right here. We could have used, we could have used this right here, these two right here, and let's take a look. Well, I'll do it in blue. So here it goes straight up 1, 2, 3. It actually goes up 3 spaces. You know what? I'll put it over here so it's a little bit easier to see. So, whoopsie. It goes up 3, and then here it goes to the right 4. And isn't 6/8 also equal to 3/4? And it absolutely is. In fact, if we wanted to repeat that slope one more time, where I go up 3 spaces, and over 1, 2, 3, 4 spaces, to the right 4, I would end up at that dot. So we'd have to do it 2 times right there, kind of a stair-stepping method. So that's how we can use rise over run for slope. Now that's going up. This is called a positive slope. What if we have something like this, where it goes downwards? And for this one, I will have m again be our slope, and it's divided by the rise over the run, which is the change in the y values. So this time we'll go from this dot to this dot here, and it's going down. So 1, 2, 3, 4, 5. So it goes down 5, and to express that, we need to call it -5. So the rise, or the vertical change, is going down 5. And then it goes to the right, only 2. So it goes down 5, and it goes to the right 2. So down 5/2. And that is it. And you might be thinking, well, that's equal to -2 1/2, but no one does that, because this what we have as -5/2 is way more useful, because the -5 is our rise and the 2 is the run. And that's a lot more instructive. This is actually, I prefer this because it tells me, oh, go down 5 and go to the right 2. If I had something like negative 2 and 1/2, what does that tell me? Do I go down 2 and up 1 and to the right 2? Or like, how do I do that? So we don't use that when we're talking about slopes. It's okay if it's improper. It's usually a simplified improper fraction. So there is slope when we have a graph. Now, we also need to look at what happens when it's horizontal or vertical, that line. And we'll look at this one here. This is a horizontal line. And let's use, yeah, okay, red is okay. We have these two dots. What's the rise? So the slope is the rise over the run. So the rise, when we go from one dot to the next, we're not going up and we're not going down. So that rise is 0. And how far are we going to the side? The run is 1, 2, 3, 4, 5, 6. 0 divided by 6. Well, that's 0. So we call that a 0 slope. Any horizontal line is a 0 slope. And let's look at this number 24, a vertical line. Well, we still have m is slope as the rise over the run. So I have that all set. And we have these two dots here. What is the rise? The rise goes up 1, 2, 3, 4. And so that's 4. And you might be thinking, well, how did I know I was going up? Well, it could be going down too. It really doesn't matter. In these vertical lines, you'll see in just a moment. So I could have called that positive 4. I could have called it negative 4. But the run, what is the run? Well, how far do I go horizontally from one dot to the next? I'm not going horizontally at all. I move as absolute 0. 4 divided by 0, you can't do that. Try it in a calculator. It gives you E for error, or ER, ER or R, or undefined. You can't divide by 0. Any vertical line ends up being an undefined slope. And so you have all the different types. And so now we're going to talk about grabbing it from an ordered pair. And in fact, I can use this very ordered pair right here, which is negative 6, 1 and 4, 8. So I repositioned this. I reminded you that m is the slope. That's the change in y or the change in x, which is the rise over the run. And that is also the same thing as what you see in textbooks as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now these are not, these numbers, these little bitty numbers right here, these are not exponents. They're called subscripts, and they're labels. Okay, so where are these labels? Well, they are officially here. This is the x number. Remember, it's x and then y in every ordered pair. So this is x and this is y. And since the first one is the first point, we'll call that x sub 1 and y sub 1 because that's the first point. And then the other one is the second point, which is x sub 2, y sub 2. Okay, and now hopefully you can see that this feeds into y sub 2 is right here and y sub 1 is here. X sub 2 goes right there and x sub 1 is right there. So what does this look like when we substitute everything? Well, it looks like this. Y sub 2 is 8 minus x sub, minus y sub 1 is 1. And then x sub 2 is 4. And x minus x sub 1. Here comes the trick. X sub 1 is negative 6. So that's minus negative 6. See what happened there? That's important. So we have 8 minus 1 is 7. 4 minus negative 6 is 10. And that is the slope. So now we've covered so many different ways, well, two main different ways, the graphs and the points, and how to calculate slope. In fact, if you wanted to verify this, I could put this on a graph. I'll show you that. So I've got a graph which could hopefully work okay. We have the point negative 6, 1. I'll plot that. Negative 6, 1 is negative 6 on the x, positive 1. So negative 6, 1 is right here. And the other one, 4, 8, 4, 6, 7, 8. 4, 8 is somewhere around there. It's kind of off the graph. And we have this. So what's the slope of the line that connects those 2 points right there? Well, we would go vertically. We go up 1, 2, 3, 4, 5, 6, and then it'd be one more 7. So it'd be up 7, and it'd be over 10. So this should be 1, 2, oops, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7 and over 10. And that matches the slope that I got right there. So it all